Hi, this is Mrs. LaBarbera. This is AP Physics Mechanics C. Today's topic is about conservation of work, energy, and conservation of momentum. Here is an example from past AP exam. Massless spring with force constant K equals to 400 newtons per meter is fastened at its left end. So its left end is attached over here to a vertical wall as shown in this figure 1. Initially, the block C mass 4 kilograms and block D mass 2 kilograms rest on the horizontal surface with the block C in contact with the spring, but not compressing it or stretching it in this case, with block D and in contact with block C. So these two are just resting over there, spring is in its natural length. That's the initial position in figure 1. Now what happens is the block C is moved to the left. Block C is moved to the left, compressing the spring at distance 0.5 meters, and is held in place while block D remains at rest, as shown in this figure. Part A, determine the elastic energy stored in the compressed spring. So from your reference table, the elastic potential energy is 1/2 kx squared. So we know K is 400, we know X is 0.5, simply substitute your number in, you should have elastic potential energy is 50 joules. Now let's take a look what happens. Block C is then released. If you release the block C is going to move to the right toward block D. The surface is rough and the coefficient of friction mu between the block and the surface is 0.4. The two blocks collide instantaneously and stick together and moves to the right together. Remember that spring is not attached to C, so the spring just released to the natural length, then the block C gaining speed and move with D to the right. You have to determine each of the following. First, the speed of VC just before it collides with D. So right over here to its original length, what is the speed? This is work energy theorem. So work energy theorem says the work done by all the other force equals the total change in the energy of the system. Let's see what's the change in energy. Before, when you compress it, you'll have elastic potential energy. At this point, when it's released at this point, C has kinetic energy. So the block spring system would have the kinetic energy is the energy after, and elastic potential energy is the energy before. And this work other is none other than frictional force. So work done by frictional force, from here we can solve for K, by the way, equals to WF plus UEL, and this K is just 1/2 mvc squared. We also know work done by friction force is negative mu times N times D, the force of friction times the displacement. This is negative because the friction and the displacement are always in the opposite direction. So it's cosine 180, that's why it's negative. Also, another way to think about it, friction always decreases the total energy, so it should be negative. Now you simply plug everything in and you solve for VC. VC is 4.58 meters per second. This is continue from last part. Now, the speed VF of the block C and D just after they collide. So C over here, right before it collided with C, we figure out the speed. The speed was 4 point some meters per second. Now it's going to collide with D and the two are going to stick together, move together to the right. So what is the speed of the two move together? This is a case of conservation of momentum. P before equals P after. The system consists of C and D. So before, the total momentum, only C is moving. After, both C and D are moving. So before C is moving, m, that's the mass of C, velocity of C right before it collide with D. This is after two blocks are moving. You'll have the speed times their common speed. So you solve for VF, 3.05 meters per second. Part D, what is the horizontal distance the blocks move before come to rest? So now these two going to have a speed and they're going to come to rest. So this is, again, it's work energy theorem. So this one we can use the work energy theorem says the change in kinetic energy is the work done by the net force. So in this case, the net force is friction force. That's a friction force doing the work. Again, friction force does negative work equals to negative mu mg. That's the force of friction times displacement. Again, it's negative because friction displacement are in the opposite direction. So over here is changing kinetic energy. Finally, you come to rest. The beginning, this is the total kinetic energy of the two block system, equals to negative mu times mg. We said g can be 10 and d. We solve for d. In this case, you see 4 plus 2 and 4 plus 2 can be cancelled, and you solve for d, 1.16 meters. I hope it helps. Thanks for watching. See you next time.